My name is Masoud Baghelani, and I'm a postdoc fellow with the University of Alberta, and I'm presenting wireless sensor technology for heavy oil applications. So the main method for extraction of bitumen as the heavy oil is the steam-assisted gravity drainage called SAGD. And for SAGD, they have two horizontal pipes in the well. They have very long, and they put in top of each other, and the top one, they inject very hot steam through the top one, and they extract the bitumen from the bottom one. So because bitumen is very, very viscose, it's not easily extractable using like the conventional oil. So they needed to increase the temperature of the environment. So that's the reason they inject very hot steam at the top pipe. At the bottom pipe, they have water, because they injected the steam before. They have bitumen and clay. So these are the three materials that are extracted through the bottom pipeline. But this requires a very large amount of water, and it's very high energy intensive process and require high gas emission rates. So altogether required a demand for real-time monitoring of the process during the extraction. So for example, just considering the required amount of water for this process, we could use this data from Oil Sand Magazine in 2018. Let's compare the irrigation agriculture water consumption in Alberta is just 44%, while the oil sand itself is 8% of the whole water consumption. It's about the municipal water consumption is 11%, so the oil sand is comparable with the whole municipal water consumption. After production and refinery processes of bitumen, it should be transported mostly through pipelines. But pipelines are unfortunately have a big problems of breach through the pipelines or spills because of loose fittings or not appropriate endings, and etc. And it's cost about $18.7 billion annually. And that's another problem that we're going to address by monitoring the pipelines in a real-time fashion to be able to detect any breach during the process. So we developed the sensors, the microwave sensors that are able to monitor the water breach as well as measure the concentration of water, clay, and bitumen in downhole. These sensors are copper traces formed as a split rings, and they're extremely low cost. They're very high sensitive because when you put the material on top of them, they're able to detect the variation of that material because each material has its own dielectric constant. And also it's non-contact, that this structure is comprised of a very simple tag, which as said, it's a very thin sheet of copper, and it's electromagnetically coupled with a reader. So the reader doesn't need to have any contact with the material under the test. And so the structure is non-contact and non-intrusive, and it's able to work in harsh environmental conditions, just a simple metal layer without any electronic device. It doesn't require a battery because the coupling is electromagnetic. And it's also an ideal for Internet of Things applications, which we can hear about all over the place. So these are two samples of our experiments. The one in the left was the sensing mechanism for bitumen monitoring that we have done at a very high temperature of 210 degrees C under turbulence, and we're able to monitor the bitumen and water concentration at that high temperature using this sensing mechanism. And for the right one, we were able to determine the water contamination in biofuels with multiple variable mixture using artificial neural networks and the developed microwave sensor. All the works that we were doing in the lab is that they are dedicated to the memory of Professor Mujgan Danishmand, who passed along with her family in January 2020 in the Ukrainian International Airline Flight 752 tragedy in Tehran. My special thanks goes to my colleagues in end-to-end lab, especially Zahra Abbasi and Nabi Hussein.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.